Hello and welcome back to Steaming with Steve. Today we're going to keep going on with our learning about how Python works when reading files. And specifically we're going to learn about how relative files work. So let's jump on in. So a relative file is a little bit different from a sequential file. So where a sequential file goes in sequence, a relative file allows you to find information relative to a key that you use at the front. So some of the learning intentions we're going to do today is we're going to understand the concept of a relative file and their importance in data storage. We're going to work out the difference between a relative and a sequential file, and then learn how to create, read, update relative files with a focus on CSV files. So it's a little bit different. Then going to apply some Python programming skills to handle the relative file operations. So a relative file is a little bit different from a sequential file that we just did before. So a relative file allows for a whole heap of data to be found based off a numeric ID as a key to reference it. Now this is sort of leaning into what databases do. So an example of relative files include a CSV file, which is basically a comma separate file, where each row has a bit of data separated by a comma, an Access database file, or a MySQL database file, a NoSQL database file. There's a whole heap, basically any database file. So for the purpose of this lesson, we're going to only deal with a CSV file, which would look something like this. So the first row gives you some variables, so you understand what the data is underneath it at that position. So I'm guessing this is the employee ID, and then there's a whole heap of numbers. There's a last name, then a first name, and then a date of birth that's separated by dashes between each one. Now, this is what a good data scientist looks for, because there might be patterns here that you'll be able to sort of clean the data and make it in a way that's more useful. So you might want to, work out the year that everyone was born. So how would you go through and pull that information out and work with it? You can also open up a CSV file in Excel, which is really useful because the columns kind of help differentiate the difference between each thing, and you can see the data a lot sort of a bit more cleaner. So you can open up in Notepad, but my recommendation when dealing with CSV files is to open it up in Excel. So is it easier to search for a number or a word? Just pause the video and have a bit of think. Now, hopefully you've picked up from our very first lesson, numbers are a lot easier for a computer to understand, because essentially what they do is they come down to zeros and ones. So the answer to this is a number. I've seen a lot of databases that use primary keys that are words, and then they wonder why the database works really slowly. A number is a lot easier to process and also find inside of a whole heap of information. So it's really important when we make those primary IDs at the start that we use numbers. So what is a CSV file? That's what we just saw before with the comma separated thing. So a CSV file is sort of a relative file. So CSV stands for comma separated values file. So each value is separated by a comma, and allows for a set of records to be stored in an organized way. So each element of a record is separated by a thing called a delimiter, which is in this case a comma. You can change that delimiter around in different files, but generally we use commas. Each record is then separated by a new line, which then brings it down. So this is what we talk about a record. So each row is a record, and then that's how the CSV file is built. This first row stores the names of all the variables to be stored. So that's what that first row does. And then the first column needs to be a numeric ID, allowing for the record to be found more easier. So that's what I was talking about before. By having a number here, that has to be unique. And then you'll be able to look up, for example, 7834. It quickly goes down, finds 7834, and then it knows that Frank Kirby was born on that date. It can also be created in Notepad or Excel. It doesn't really matter. So what's the difference between a relative and a sequential file? Well, relative files are faster to find the records because it's just looking for that key and not reading the whole row. It can store more complicated data and allows for the updating of parts of records. So you can go through and change just one part if you wanted. So for example, in that previous example, the birth date might be wrong for one person. You could just change it and not have to rewrite the whole file. Sequential files are easy to learn when starting off to work with the files, and that's pretty much all that's benefit of a sequential. So in this case here, if I wanted to override Frank Kirby to be Stephen Henderson, that's basically what we could do in a relative file. sequential, not so much. So creating a relative file, most databases will follow this process. So relative files need to be opened for relative access. When they are created, they must be also closed like a good samurai before the program ends. So all records are accessed through the use of a key, which specifies the relative position of a record within the file. So the key field must contain a unique positive integer value, and then no sentinel value is written as the file is not accessed sequentially. So creating a relative file, here's the nested version of it. Basically, we go through exactly the same process before. So we begin, create a relative file, but then we say instead of just opening it, we need to open product data for relative access. So you need to use that keyword there if it says it's a relative file. Then we're going to go for I is equal to 1 to 10. Display, please enter the details of the next person. Get product number, description, quantity, and price. And then product data from product number, description, quantity, price from using product number. So product number is the primary key that we're using. And then note the use of the variable product number as the key field specifies where the record will be writing the file. Close the product data and then close the end creative relative file. So relative files need to be opened for relative access when they are accessed for either input or output and must be closed before the program ends, as we've done before. All records are accessed through the use of a key, which is what that first key there is. So I've made this little CSV file with screwdriver, hammer, saw, and hacksaw, etc. Then the quantity, and then the price of each one. So the key field must be unique. So you should see each one of these should be put in an integer, and it should be a positive integer as well. Please don't use floating point numbers or decimals here. So reading a record from a relative file, again, pretty easy. We go open product data for relative access. We go display, please enter product number for the next product you wish to see. Get the required product number, and then read the product data into product number, description, quantity, price, using the required product number that was given by the person typing it in. So note the use of the variable required product number as the key field, specifying where this record will be found in the file. So if the record is not found, which is important, then display sorry, no such product. So after it's done all that, if it wasn't able to find it, that's what will be spat out. So note the use of the flag record not found returning by the operating system. So this is what we call flag variable. So flag variables are either true or false, which are basically booleans. And then if it is found, that's what the else gets hit. Display product number, description, quantity, and price. We keep going until the required product number or whatever's been typed in is 999. So 999 is the special code that they've used to exit this program. So if they type in 999, the program ends, and then you don't have to keep searching based off that product number in the first column. So updating records in a relative file, pretty easy. Basically, relative file needs to be open for relative access, and when they are updated, they must be closed at the end. All records are accessed through the use of a key, which is what this front start bit is again, which specifies the relative position of the record within the file. The key field must contain a unique positive integer value. So updating a relative file is the necessary example. We go begin, update records in a relative file, open product data for relative access, display, please enter the product number for the next product whose price you wish to update. Please enter 999 when you're done, get product number, required product number. And then this is where prime reading has happened, because if you want to exit the program straight away, you could type in 999 here, and then it would exit the loop. So this is prime reading in its in action. So while required product number is not equal to 999, not found is equal to 0, read product data into, sorry, there should be an R there, product number, description, quantity, price, using the required product number. So again, this using word at the end is talking about the key. Note the use of the variable required product number as the key field, specifying where this record will be found in the file. So if record file not found, then note the use of the flag record not found returning by the operating system again. So display sorry, no such product, and then not found is equal to 1. Else display product number, description, quantity, and price. Is this the correct product? And then get reply. Cool. So then if that all comes through, if not product is equal to 0 and reply is equal to y, then get the new price, write the product data from product number, description, quantity, new price using the product number. So this updates the record using the data for the new price and the existing data in all the other fields. And then end the if. Display, please enter the product number that you wish to enter. Update, please enter 999 when you're done. Get the product number. So that is exactly the same. Let's go back as this. So the prime reading is actually done at the end. So then it can loop through and go back to the start. Cool. And then end the while, close the product data, and then end the update records in a relative file. That was a lot. So you can also do this all in Python. So we can use a library called the CSV file. And what happens here is you're going to then now specify the relative path to your CSV file. So file path equals your file name .csv. And then you can open the file using read mode. So with open, file the name R as file. And then this is where it's a little bit different. Instead of just read, we have to use the CSV library and the reader that's built into it. So we now go reader is equal to csv.reader of the file. It will then loop through every single file, a row in the CSV, and then print out the row so you can get access that way. So we're going to do a little example now, unpackaging that. So let's create an example that reads a CSV file containing the list of famous landmarks all around the world, their location, and interesting facts about them. So we've got the name, the city, the country, and then the fact. So we've got Eiffel Tower, Paris, France, and then it was constructed in 1889. Let's have a go of this in PyCharm. So I'm going to use the testing ground that we just used previously. Please forget about all that previous information. And I've uploaded the CSV here already, so I've typed that up just to make it a bit easier. So I've got the name, city, country, fact, and then all the information. Because of the add-in that we use with Rainbow CSV, this actually becomes a little bit easier to see the pattern. That's why I love, again, PyCharm is really cool and super useful. So yeah, let's get into this. So first step, we want to import CSV, which then allows us to read these CSV files. We're then going to def read the landmarks. And we want to read a particular file name that we're going to put into this. So we've made a separate function. So if we've got other files that we want to use the same function, we can now do that, which is really cool. So then with open, which is what we've done before, file name, comma, and then I'm going to set the mode is equal to R. And then the encoding, we haven't really talked about this before, but UTF-8 is a way of storing Unicode with 8 bytes. And then we go as file. So now I'm going to go CSV reader is equal to CSV.reader of the file that we just opened with the with command. And then we can actually access the next function, which will then pull out the next CSV reader, which will then skip the header row. So that first row that says the name, the city, the location, and the fact, that gets skipped by doing that. For row inside the CSV reader, snaky bind. I'm now going to print out each bit. So I'm going to go print f string, and I'm going to print out the landmark. Is equal to row at position 0. That's the landmark that we chose at the start. And then I'm going to be a little lazy here. Copy, paste, paste. So now 1, 2, 3. And instead of landmark, the next one I think was city. The next one there was the country. And then the last one was the fact. So then that should go through and print out each one. And that's the whole thing. So now I'm going to call that function that we just created, landmarks. And this time we're going to go landmarks.csv. Hopefully. We run this and see what happens. Oh, got an error already. Oh, quotation marks. And this is why I love PyCharm again. I know I keep saying that, but it makes your process a whole heap easier when you try and do this code. And there we go. So I went through, found city, landmark, and the fact. Just for the giggles, let's do print another line, just so that it does a new line underneath each one. Cool. Not so bad. And then does everyone see that was really cool, because instead of doing the row and printing out in sequence, you can now sort of control the individual parts, because this is what the CSV reader does. You can also do this in pandas. I'm not going to unpackage that much, but pandas is a separate tool that allows you to do some really interesting data work, particularly with data frames, but that's way beyond the scope of what I'm expecting you sort of know. But just so that you know it exists, it's kind of neat that that's there. So pandas basically allows you to do CSV reader, but it's a really advanced version. So this one here, oh, I've already given the answer, sorry about that. So which row of the table correctly describes the features of a sequential file and a relative file? And that would be C. So C can be opened in append mode with sequential, because you can add it on the end, and relative allows the updating of an existing record in place. I've done it again, sorry about this. So which row of the table contains a true statement for both sequential and relative? And the answer is A. So sequential files allow a priming read is used to check that the file is not empty, whereas relative files must include at least one integer field. So if it doesn't have that integer field, particularly for that first row, it's not so good. Which row of the table correctly compares features of sequential and relative file? It's D. So records are accessed from the beginning of the file, and then relative records are accessed using a key. So some conclusion questions to think about. How would you use relative files in managing a real-world data, like a library's book records? Can you imagine a scenario where a sequential file is more suitable than a relative file? And then what challenges might you face while updating a record in a relative file, and how could you overcome that? So there is a little Kahoot that I've built at the end here. Super useful sort of to practice the skills that we've talked about today. And yeah, that's pretty much it from me. So hopefully you now understand the difference between sequential and relative files. Generally speaking, you would use relative files a lot more than sequential, but again, sequential, great for sort of when you're starting off and learning how to code. If you have enjoyed this video, please give us a like and subscribe down below, as it does help with that YouTube algorithm. We're trying to improve the uptake of people learning Python, and that's the whole intention behind this course. And yeah, if you have any questions, please pop them down below. That's it for me. Thanks again. See you next time on Steam with Steve. Adios.